will proceed in curl, curl in vector field. We are moving towards commercialization, commercialization in calculus. So we are moving towards commercialization in calculus. Okay, and we are in discussion for the curl. What is what is curling? Okay, so what is curling? So that is in question. If I have a vector field, what is vector field? Okay, so if I have a vector field, then what is vector field? Vector field is it is also called vector factory. Means vector field is called vector factory in a sense that vector field is a vector of algebra where each component of vector field is algebraic equation. If I have a vector that is 2i plus 3j, then its components are numeric, static. This is a static vector in one direction. But if I say I have a vector that is xi plus yj, xi plus yj, then if I keep changing an x and y, then I get different vectors. So this is vector field. Vector field is a vector which produces different vector depends upon the xy independent variable. So it can be considered as a vector field is a function that provides separate vector at separate coordinate at separate xy coordinate value. So this is a vector field. Okay, so this is vector field. Vector field is a kind of algebraic vector which, depending upon the xy coordinate, it produces different vector. What is curling in the vector field? So, vector field, since it is at all, after all, it is a vector. So, if I have a vector, consider this is a force vector. If it is it can be force vector, it can be a velocity vector, it can be electromagnetic field, it can be magnetic field, it can be gravitational pull whatsoever. If there is a vector, then if there is a vector, this vector is a vector field provided the component of vector are algebraic. Depending upon those independent variable values, different static vectors are coming into the picture. What is curling? This is what the discussion is. What is curling in the vector field? If this is the vector field, if this is the, consider this is what we are taking, right? Consider this is a river. River is flowing. So river has water and it is flowing like this. So this is the width of river. A river is flowing from left to right. So this is the current of the river. It is going from left to right. It has one bank of the river is here and one bank of the river is here. If river is flowing like this, I place any item in the river, will it rotate? If it flows like straight like this, then there is no rotation seen in the river. If that is the case, then river vector has no tendency to make anything rotate. What is its tendency to make anything rotate? That is curling. If I say my river vector, river has a force vector of F, or river has velocity vector of V, or river has a vector field F, capital F. What is the tendency of vector field F to make anything rotate? That is the curl nature of a vector field. Consider that I have a vector that is round. Vector field means I have set of vector. I have put an algebraic equation into the vector field in a way that x and y component, if I keep changing, then it will become a circle. Possible, right? If I have considered the vector as cos theta I plus sin theta j. If this is a circle, then position vector is cos theta I plus sin theta j. X equal to, where radius is 1. So 1 cos theta I plus 1 sin theta j. If that is the case, then this vector is rotating and this position vector is changing as per the theta is changing. So every moment it is generating different vector based upon the theta. This is a vector field. Here, vector field, it has a position vector at some theta. If I change the theta, then position vector is here, position vector here. If I calculate the gradient of this vector, then it will be this. Again, this vector is changing depending upon the theta. Or if I have in algebra, if I have a, a equation that is y equal to a square root of a square minus x square, or x square plus y square equal to a square, that is the equation of the circle. What is its gradient vector? Gradient vector of x square plus y square equal to a square is 2xi plus 2yj. 2xi plus 2yj. 2xi plus 2yj. If that is the case, then depending if it is x-axis, then y is 0. Then 2xi will go in this direction. Here, x is 0 and y has some value. It will go in this direction. Otherwise, it is like a radial vector. But this vector will keep changing as you change the x and y. So the vector field is a vector whose components are algebraic equation with some independent variable. You keep changing independent variable and vector will keep changing. What is curling? Curling is something like if I place some item inside this vector field, you see it is a field, magnetic field, electromagnetic field, earth gravity field. Field means if I have a vector, like consider I have a vector that is 10i. If this is x-axis, then I have a vector that is 10i. Then it is along this only. But 10i vector is magnitude and direction. So if direction is along x-axis, all are 10i only. If I don't go with parametric vector, then all are 10i only. All the parallel vectors to this are 10i only because they are going in along the I direction. 10i only. So this is a vector field. Can you see this? This is a vector field. Vector field means it is along x-axis, and if I move it along like this, then it creates a kind of a thick vector field. If this is the vector field, inside this, if I keep any item this, then this item will be pushed from left to right because vector is going left to right. But if it rotates in that vector field, then this vector field has tendency to rotate. How much it is? That is curl. Curl of a vector field is tendency of that vector to make any, if that vector has a vector field, if I place any item in the vector field, what is its tendency to rotate it? That is the curl of the vector. But this story begins with path independence, line integral. These are the terms that starts at the beginning. Okay, what is line integral and what is line integral and what is path independence? Okay, now consider consider this is x-axis. This is x-axis and there is a force whose equation is 2i. Force equation is 2i. Means force is 2 power of 2 and its direction is along x-axis. 2i. How much is work done along x-axis when an object it moves an object x distance? If vector is 2i, it is going in I direction. Strength is 2. I want displacement in I direction only. So, alright, means they are in same direction. So, I can directly multiply the vector power, that is force vector, and displacement. If displacement is 3 and vector is 2I, then 3I is the displacement. How much is the work done because of the vector? It's vector energy, that is 2 into 3. How much work done when the displacement is x? 2 into x. Consider this vector is xi. xi. If vector is xi, then how much is the displacement? And this vector is xi. Now, how much it work done xi? How much it does the work when it is moving any mass from a point A to point B? When the equation of force is xi, so force is in xi means whatever is magnitude, its direction is only x-axis, xi, but its strength of the vector is 0 at the origin. At that moment, force is 0. But as you go along x-axis, force is increasing. Work done is force into displacement. So as you go along x-axis, at that moment, if you make a small displacement, also work done will be becoming more and more and more, because force power is growing. Force power is xi, then work done is growing. If you make same so at origin, if you make a small displacement, then work done will be less because force is less xi. But if you go at 10, then force is 10i. At that moment, if you make a same equal displacement, then work done will be more. If you go at 100, then force is 100i. If you make same equal distance movement, then work done is more. If that is the case, then what is work done? Work done is nothing but force into displacement. Force, force into displacement. If you are making displacement along x-axis, then force into x. But since it is algebraic multiplication, we will come into calculus. Force into dx, f dx. What is work done? F is x dx. Work done is x square by 2. Limit is from a to b, because I want to calculate work done from a to b. Work done is from a to b. Work done is from A to B. What is work done from A to B? Very simple. Fx, force, force dx, force into displacement, F dx, and A to B, x square by 2, A to B, B square by 2 minus A square by 2. That is the work done. Very nice. What is the work done from B to A? Then it is A square, A to B, B to A, B to A, then it is A square by 2 minus B square by 2. What is work done from A to B and B to A back? If you add this, what is the work done? 0. Work done is 0. Understandable, right? Now, what is the equation of work done? Fx, F force vector dot dx vector, dx vector, or rather I can say F vector dot dr vector. dr vector. In what direction? This is called line integral. Line integral means you are calculating the integration along a direction. If it is along x-axis, then it is f vector dot dx vector. If it is along any direction r vector, then it is f dot dr vector. So means whatever, if this is x-axis, this is y-axis. I want this force, that is xi, along work done along x-axis. F vector dot dx vector. Since both are in x direction, so dot will result into nothing. Okay. What about in any direction r, where force is x along the x-axis only? If that is the case, then f vector dot dr vector. So this is called line integral. Integration of a vector along a particular line, not necessarily x-axis, y-axis. Because I am interested in, if this is the force, I am interested in how much work it will do when I am moving a particle from point A to B along r vector. That is f, then f will not have that much strength as far as r vector is, because f is in our x-axis. If this is x-axis, if this is x-axis, then f has full power along x-axis. But if I am calculating f along any r and r is exactly perpendicular to the f, then f has no power in the y-axis. F cannot move anything if something is along y-axis, because f can move anything maximum power along x direction. If it is x-axis and if it is f, then it can give its best to move something along x-axis. But if it is rotating like this and f is this, then work done will be less. If it becomes orthogonal to f, then work done will be 0, because it cannot move anything in x direction, in y direction. It can move everything in s direction, but things has to move in y direction. So no work done. So work done, if f vector field f is a force, then f vector dot dr vector, f vector dot r vector, but it is calculus, so f vector dot dr. It is highly advisable that please watch all calculus videos, all, not by mistake with any single video. So if that is the case, then this is the condition. Now if I say what is the work done f dot dr from a to a, consider r is x only for simplicity. So x axis and f is also along x axis. What is the work done from A to A? A to A. Anyone will laugh, right? What is A to A? Nothing. If I have point A, from there only you want work done from A to A, means it is not moving at all, right? Then no work done. A to A. Not necessarily. This is path independent. A to A work done is also work done from A to B and B to A. The work done from A to A is equal to work done from A to B plus B to A. That is also true in calculus vector. So if 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 I have a weight that is kept at A and there is a vector field like this, force vector field, then what is the work done by force from A to B? Positive. What is work done by this force from B to A? Negative. If you add this, it becomes 0. So this is the work done or line integral. Line integral is nothing but work done when vector field is force and r vector is distance. Both can be different. Not necessarily that vector field is force only, and not necessarily that r vector is distance only. But here the vector field f is force and r vector is distance along x-axis. What is the line integral or what is the work done from A to A? 0. A to A is also A to B and B to A. 0. Because one side it is positive, equally it is negative in other side. Okay. What is, if that is true, if this is point A and this is point B, then consider a rectangle. Oh, consider a rectangle. This is point A and this is point B. Then there is a rectangle like this. One side like this, other side like this, and then other side like this. And then there are four sides. Can you see it? So this is rectangle. One side, two side, three side, and there is one more. Four side. A, B. Okay, this is x is again A and x is again B. What is the work done from A to A? Then from A to here, then from here to here, from here to here, from here back to here. This is also A to A. If this is the force is along x-axis, then work done from here to here is 0, because it is completely y-axis. Then work done from here to here is f dx from A to B. Work done from here to here, again 0, because force is in this direction. Then work done from here to here, negative of what we did from here to here, then work done is again 0. Very nice, right? Work done is again 0. Oh, okay. Next I am taking. Consider the force is xi. Right now the force equation is xi. Force equation is xi. Force equation is x into yi. If this is y-axis, this is x-axis, then force when y equal to 0 and force when y equal to 2, force is different. The magnitude of the direction is I only, but magnitude of force is varying. Can you see it? Force here, when y equal to 0, when y equal to 0, or force is x plus y. This is better one. Force is x plus y. If y is 0, then force is xi. Same thing what we had earlier. But if y equal to 10, then force is x plus 10. Then this force is more powerful. Now let's calculate the FDR. FDR. Then FDR from A to B, from A to A. Then again from here to here we'll calculate the force work done from here to here, here to here, here to here, A to A. Here to here 0 because force is in this direction. Here to here, then height is 10. Then it is x plus 10 dx because it is in dx direction. X plus 10 dx. From A to B, whatever comes, keep it. And then in this direction that is perpendicular to the force, again 0. From B to A, when y is 0, then x dx. This is minus x dx because opposite direction, and it is or B to A, it is A to B. Okay, and here it is x plus 10 dx. Here it is x dx, here x plus 10 dx. Net will not be 0. There is no guarantee that f the line integral in a closed loop, that is from you start from a place and go all the while a comeback, there is not necessary that from A to A, the line A to A, the line integral will be 0. No guarantee. This is what I am trying to say. There is no guarantee that A to A, the line integral is 0. A to A calculus is 0. Not necessarily. If it is 0, now if it is 0, because f is xi, if I take rather than taking a rectangle, if I take a circle, if I take a circle where force is again xi, everywhere it is xi, everywhere it is xi. This is x-axis. If I start from a point and go around it and calculate the FDR, come back to A, so A to A, FDR, where R is circle, the path is circle. If I take like this, then if I do FDR line integral, then R is a rectangle. I divided into 4 parts. But if it is a circle, then R is a circle. FDR, F is xi dot dr. R is a circle, cos theta I plus sin theta j. Cos theta I plus sin theta j, or cos ti plus sin tj. Okay, if that is the case, then x becomes cos t. Cos ti xi, cos ti plus d of cos ti plus sin tj. Then j will go off, then cos ti, d of cos ti will become minus sin ti. If you do dot product, then cos t sin t minus cos t sin t, you have to integrate from t. T when we are taking, then it is 0 to 2 pi, 0 to 2 pi, cos t sin t, 0 to 2 pi, 0 full 0 and 2 pi full 2 pi. Okay, then it will be 0. Or you can, if you are not satisfied, you are happy to break into different parts, whatever it is. What we are talking is, if this is x-axis and there is a circle, and there is a vector, if this is x-axis, consider the circle is centered at the x-axis, better word, and this is y-axis and there is a vector field like this. If I start from a position and come back to that position, A to A, what is the line integral? For rectangle, if vector field is xi, then it is 0. If it is not xi, it is x plus yi, then it is not 0. In circle also, someone can compute it that if it is 0. We'll try it. X plus y. X plus y. Okay. And then along dx. Mind it. Along dx. So along dx. So if that is the case, then equation is cos along dx. So equation is, if it is x, someone can calculate. What I'm trying to say, someone can calculate. If it comes as 0, if it is x plus y, if it is x plus y, and it is not 0, x plus yi, x plus yi, it is not xi plus yi, it is x plus yi, x plus yi. If it is a rectangle, then integration from a to a is not 0. If I draw a circle, path is rather than rectangle if it is a circle, and if I draw again a to a, and if it is again not 0, whatever it is, okay, then it is not, if I draw a rectangle from a to a, it is not 0, means it is not path independent. But if it is path independent, then if I take from a to b, a to b and b to a, if I add, it should become 0. If I take a to here, here to here, here to here, here to here, again it is 0, then it is path independent, candidate for the path independent. Now, if I take a circle, same equation, x plus yi. If I take a circle, this is a homework, someone can try, x plus yi. If this is a circle and I start from same point and come back to the same point, again it is 0, then if I take another shape, everywhere it is coming 0, means this is path independent. Path independent in a way that it does not depend upon the path. It depends upon the begin and end point. If begin point is A, end point is A, certainly integration of A to A will be 0. If that is the case, it is everywhere it is 0. Either it is circle, it is a rectangle, it is any shape. If I prove that through any shape it is 0, then vector field is called path independent. And path independent means what? Now it is considered as path independent, right? Because if you take a straight line, if I take a straight line, then A to B and B to A is 0. If I take for x plus y I, x plus yi when y equal to 0, then if I take a straight line, then it is 0. But if I take a rectangle, it is not 0. Then it is not path independent, because A to A should be 0. Then consider for rectangle also it is coming as 0, line it is also coming as 0. But if I take a circle, it is not 0. Then certainly for all paths that go from A to back to A, for all possible paths, if this is 0, then it is called line integral is path independent. Only thing is varying is limit. Only thing that is it is dependent. Line integration is dependent only on the limit. That's it. If it is A to A, then it is 0 as per the integration. Then it is independence of the dr. F dot dr vector. It is not dependent upon the r vector. R vector can be a straight line, it can be rectangle, it can be circle, whatever it is. Okay, this vector field, the vector field is not dependent upon the line equation. So whatever resultant will come, it is dependent upon the lower limit and higher limit. If it is A to A, it will be 0. Rather than you take a straight line path, circular path, rectangular path. If that is the case, it is following the rule of integration, then it is path independent. We will talk more on it.